Thank you, everyone. And the timer has already started counting down, so we are officially back on schedule, and it's time to get going. I'm glad to see a good set of folks here. Hopefully some more will trickle in. But I say that because I get the impression, walking around the show, and it kind of feels like this a lot of times, that the core doesn't always get the respect that maybe it should. I mean, I feel like this year in particular, the RAN, we're kind of talking about 5G, and we know what 5G NR maybe looks like. We're getting closer. We all want to talk about M1, NB-IoT. There's so much focus on the RAN that I get the impression that the core sometimes gets a little bit overlooked. So hopefully we can maybe dissuade you of that, or at least give you an idea that while we're figuring out the RAN, we can actually start doing stuff in the core. And I think we have the right set of people to talk about that. Particularly, one of the reasons why I am actually really excited about this panel is I think the good folks at CTIA have done a great job of setting up a good representation of what's going on. Right? We've got network incumbents, Ericsson. We've got network innovators, and sort of coming from more of a startup background, whether it's Affirmed or niche. I don't know, Brocade, do you call yourself
Brocade.
part startup from the history, but now within the context of a larger firm? So that's a great combination. And then, of course, we've got operators who are working with all those folks to give some background there. So hopefully you will all get a lot out of this. Before we start, let me just do a quick check. Can we get a feeling for who's in the audience from a service provider perspective? Anyone here from the service providers? Or do you just not want to admit it? Okay, I see a couple hands. That's good. Service providers. Vendors, the vendor side of things. Okay, that's probably a good mix. So what we're going to do, we're going to go through and introduce all of the panelists. They're going to each talk about maybe 3-4 minutes talking about where they're coming to from the core. I'm going to launch into some questions, have a conversation. Hopefully we'll make it a conversation, not just questions. And then if we have time at the end, we'll save some to take questions from you all. So if you've got some pressing issues or questions you wanna dig up, things that we're not talking about, think about those, save them for the end, and we'll dig into that. So does that work for everyone? You're a small enough group, people can argue. Cool. So now that that's done, I'm gonna sit down and actually let's just start. This is not the speaker order here, but that's fine. We can switch it up. So Glenn, why don't we start with you and talk a bit about your background and who you are, and I'll sit down.
Thanks, Peter. So I'm Glenn Laxdal, the head of strategy and CTO for the North American region for Ericsson. And Ericsson has been pretty deeply involved with our customer partners, going back for probably more than 2 years now in I'm going to say the evolution to 5G and enabling the core for the introduction of 5G. So we need to start in 5G and work back from there. We see 5G as being sort of more than any other air interface use case defined. And so there's going to be a multiple of use cases that will be stood up on this 5G end-to-end infrastructure, all the way from very narrow band use cases like the Internet of Things or massive machine type communication, critical use cases that we would call critical machine type communications, connected cars as an example, autonomous driving cars, all the way to broadband types of use cases, so massive broadband everywhere. And if you've got the requirement to set up a core network and evolve a core network to meet these multiple use cases, you want to be able to do that in software, not in hardware, so that you can set up and tear down network resources across the network to meet the needs of the application that is asking for those network resources. And we call that concept network slicing. And so if you start with the concept of network slicing and move back to what you need to do in the core, you need to do the building blocks in the core that we've been talking about: network function virtualization, software-defined networking, establishing a cloud infrastructure that you can run your network functions and host your network resources in, and then be able to distribute that cloud from the core data center all the way out to the central offices, all the way out, in some cases, to the eNode Bs. So now you've got a core network that is a highly virtualized, distributed core network that goes all the way out to the eNode Bs. And then we can, in software, set up the network resources that we need to meet the needs of the application, this concept that we call network slicing. So all of the technologies that we're innovating in the core now are going to be used in the transition from 4G to 5G. And for a long time, 4G and 5G are going to be working together for a very long time, hosted in a common core, in the same core. So all of the technologies we're innovating on right now in the core ultimately lead us down the path from 4G to 5G.
Great. So I guess now we're back on order. Andre.
All right, I'm Andre Fuich with AT&T, and actually this is a little dated slide here. I'm now the president of AT&T Labs and the CTO. If you haven't heard of AT&T, I don't know what to say. We've been around for 137 years, and we've got quite a history when it comes to networking, and certainly the core network is no different there. I'll tell you from a CTO perspective, what we're focused on primarily are really three things. One is SDN and NFV, which is central to the whole the core of 5G, as we all know. We're also focused on anything mobility. So 5G, people are enamored by 5G. It's new and it's exciting, but don't forget we still have a 4G LTE network that, frankly, will be around for quite some time. And there's a lot we can do with that network too. So that's a big part of our focus as well. And then the third area is really around analytics and automation. And so, the big focus around SDN has always been around the CapEx side of the equation. We really see the bigger opportunity being more around the OpEx side of the equation, and that's where analytics and automation comes in. As far as the network goes, just to add on to Glenn's comments, 5G is a really unique opportunity for us to really change the way the network works. And this whole notion of virtualization is really powerful. Glenn said it, it's the ability to distribute anywhere you want or centralize anywhere you want is pretty powerful. And we believe if you are going to be able to network slice and serve this very wide spectrum of use cases and devices, you're going to have that flexibility that virtualization is going to bring. So we at AT&T, we've been very big on software-defined networking and virtualization. We're, in fact, if you haven't heard, we're actually open sourcing our network operating system. We call it eComp. And we believe eComp, as we're using it today in production, which has been focused in the wireline core, but also in the wireless core as well, we see that even extending out into the RAN as well. So, I can tell you we have thousands of engineers and scientists working on this, and we feel very bullish that eComp will be setting the standard here in a lot of different ways, especially with respect to how 5G will evolve as well. So that's what we're doing at AT&T.
But how many of you didn't know that? I mean, you guys have been pretty good about talking about what you're doing, so it was a good recap. Hassan, what are you guys up to at Affirmed?
Sure, so I'm Hassan Ahmed, I'm CEO of Affirmed. Affirmed is a company that kind of thrives on disruption, and so we're very excited to be in this particular market because it's a market that's full of disruption, and it gives us the opportunity to play very aggressively in the market. To give you a sense of how we've approached it, when we started the company, 5 some odd years ago, before the whole NFV revolution and so on, we felt that network transformation was going to take place because of a need to really evolve cost models and business models in the operator. So we felt there was really strong fundamental economic underpinning to why networks would change. And we embarked on evolving new network solutions for that purpose. And So our mantra is sort of we have products that allow you to build the network differently, and then we have automation products that allow you to monetize and manage the network differently. This gets to not just the OpEx part of the equation, but it gets also very importantly to the ability to quickly create services in the internet economy at a rate that's very different than what we've been accustomed to. So that's sort of been our guiding principle, and what's led us to creating the products that we have. One of the things that has been, I suppose, a happy coincidence is, when you set out to solve a problem, you try to find the best engineering solution you can imagine. And fast forward to today, when we're now thinking about 5G cores and what the architecture of 5G cores is in terms of their decomposition and so forth. And in the happy coincidence category, the Affirmed architecture is sort of built that way. And therefore, a lot of these capabilities of fine-grained network slicing and so on, our customers are able to take advantage of today in their 4G deployments. So we're just really excited about where this technology is evolving to. We're today deployed in about 40 commercial networks in 20 different countries around the world. So we're pleased with the fact that this market, which started as an idea, has really turned into what I think is prime time. And we're very grateful to you guys. Thank you for that as well.
Nishi, last but not least.
So Nishikant from Brocade, and many of you might know Brocade has been pretty serious about SDN and NFV. They have acquired few assets, they have developed few, and we were part of an acquisition. Prior to acquisition by Brocade, I was the founder and CEO of Connectum, where I would contest with Hassan that we were the first to actually virtualize the packet core and have a successful trial even before NFV paper was published. In fact, we actually looked at packet core in a very different way from an architecture point of view. One of the concepts as we do to go towards hyper-connected world, you would see that would start becoming a KPI is network entropy. How the networks are designed, how they're implemented and operated, that key parameter would dictate whether we see them as a common core, as Glenn was saying, or a collection of network that are managed somewhat differently, and change management becomes a very important aspect of it. For us, we took, instead of a node-based architecture, we took a service and transaction-based architecture, because what I would argue that traditional 3GPP architecture was very heavy on entropy or network entropy, because every transaction had to go through so many nodes to get completed. So these things you would see, taking further root as as massive connectivity happens. This is a very exciting place to be. I don't have as many implementations as Hassan, but we have a few in China and US. And going forward, we're also looking to get more entrenched in the network.
Great, thank you. Thank you all. So Andre, let's just start with you. And remember, if anyone wants to, we'll kick off the question with you, but if anyone wants to chime in, maybe give other viewpoints from other operators that you guys have worked with. But you guys at AT&T have done really well being very public about your plans. Obviously the old title references domain 2.0, but whether it was domain 1.0 then 2.0, you were really public about the commitment to SDN, the commitment to NFV, even the eComp side of things, right? Every single part of eComp, you sort of put out there what you guys were doing. Why is this so important to AT&T? And I think some of this we've seen, right? There's commercial offers that are out there. If you look at some of what's going on the enterprise side of things, or from an SD-WAN side of things, from some of those services on the enterprise side, I think we kind of see the new services. But from a mobile perspective, why are SDN and NFV so important to you guys?
Yeah, I mean, the typical reasons are cost, right? Certainly there's a lot of pressure in the market, and we need to find new ways to get our costs down. But that's just one part of the answer. It's really about, and Hassan touched on this, it's about how do we go faster? How do we lower the innovation entry barriers so that really to do what frankly the web scale companies have done with software? How do we sort of bring that into this traditional operator space. And we really saw SDN NFV as being the right vehicle to do that. And we knew that if we just did it internally, in-house in a black box, we really couldn't take it as far as if the greater community could. And so, this is part of what how a software company thinks. And so that was a big sort of transformation for us to make this change, that we are going to be more of a software company than a traditional operating company. And so that's really what was behind what drove us to this, all the things we've been very public about, and the embracing and the contribution we're making into the open source communities. So that's really what's driving this. And then when it comes to the mobile core, it's no different. All of this extends everywhere in our business. And we feel that the more software we can put out there, this then becomes an enabler to allow us to differentiate in different ways. And I mentioned analytics and automation as being some of those ways.
Are you guys seeing the same thing from other operators? Obviously, AT&T has been out there a little bit more, but as you guys work on the vendor side of things with other operators, is it the same? We tend to see a lot of the CapEx and OpEx savings side versus the new service side. What are you guys seeing from other operators? Is it the same rationale?
Yeah, I mean, I think we're on a journey. I think it's safe to say that when AT&T kicked off Domain 2.0, AT&T was at the very leading edge of that journey. But as the market starts to mature, and as we see the benefits of this more software-defined approach to creating core networks, other operators are really embracing this as well, which I think is really, really important for the ecosystem, and because this is becoming an ecosystem game. Once you've separated the application from the hardware that runs that application to an application or a network function that's running in a virtual domain abstracted from the hardware, now you can innovate at a much faster pace in that application or that network function space. And innovating at a fast pace means being able to embrace the larger ecosystem. It means being able to pull in participants from the broader ecosystem and tap into the brain power of tens of thousands or hundreds of thousands of software engineers as opposed to hundreds of software engineers. And once you move in that direction and you see the benefits of the accelerated pace of development, then embracing it becomes something that is more and more natural over time. And that's what we see right across the industry right now.
Our experience has been pretty interesting. We're actually able to measure now how it's going and what things work well and what don't. So from a motivation standpoint, certainly everybody seems to have a very similar motivation. One of the things we find, though, is that people have different approaches, and some folks will go in and take the challenge head on, which means a lot of things, by the way. It's not just the technology. It's retraining your workforce because your ops guys don't necessarily think in the way that you want them to think in managing these new networks. And our experience has been that people who kind of take that holistic approach tend to do very well. And on the other hand, we've also seen operators who say, yeah, this is really important, but they'll start by dipping their toe in the water and say, let me try it over here and let's see what happens. And almost always that turns out not to be as good an experience for them because they've got all the overhead of doing what they're already doing, plus the overhead of doing something new. And so what we find is, especially for those who are operators out there, that this kind of embracing it and taking a holistic approach seems to yield the best results. And I think it's actually critically important now because I think the market's actually crossed a tipping point where 2 years ago, 3 years ago, somebody would still be debating whether they should put a legacy infrastructure in or a virtual. Nobody debates that anymore. I mean, this is prime time. Nobody says to me, at least I haven't come across anybody who said to me, yeah, you know what, I think I'm just going to stick with my legacy stuff.
Is there a difference between large and small operators? I mean, I think we all tend to think smaller operators should be more nimble, they can move quicker on things, but if we think about who's leading the charge in terms of things like SDN and FE, we see the AT&Ts, you hear from the Vodafones, the DTs, you hear from the Docomos. It seems to be the large guys that lead the charge. Is there a difference between how we're seeing this from large versus small players?
So I would say that this has an effect on everybody. Obviously, large operators have led the charge, but it has enabled some use cases where cost of entry or cost of fear of maintaining a complicated network was a barrier. And as a result, we have a customer by name Smart Sky. They are doing air-to-ground LTE-based high-speed data. They would not have thought about using LTE if we had not happened.
Interesting. So let's maybe switch gears a little bit, and we'll come back maybe, Andre. We can talk a bit later about the progress you guys made. But I don't think it could be a technology or wireless show circa 2016 if we didn't talk about 5G. So Hassan, maybe we'll start with you. It seems like 5G in the core, it's a big preoccupation. We want to talk about what it means for the core. We want to talk about 5G in the core. Is there a reason for that other than the general buzz around 5G, or are there new things we need to do in the core for 5G? I mean, how do we think about that?
Yeah, so obviously there's a lot more focus on the radio side than there is on the core side, but there is this very important focus on the core because the core represents the vast majority of the intelligence of the network, even though it's a small part of the overall deployment budget. What we've seen up until now is almost independent network instances being built. So someone says, look, I got my consumer network over here. I want to start doing IoT. I don't want to stick that on my consumer network. It's too expensive. I'll learn about this stuff by doing a separate instance for IoT. If you actually think about what will happen in a 5G infrastructure and think about the use cases, the traffic types you're dealing with, everything from high capacity real time to IoT type traffic to low latency traffic for vehicles and so forth, the architecture of the core becomes critically important. And I think the prevalent view that the industry's landing on is that the core needs to be highly decomposed, that it has to be able to kind of match the traffic patterns on a common infrastructure. And that's broadly what people call network slicing. But at the end of the day, it's like a game of Tetris, right? You want to pack the traffic as well as you can and not have shortcomings. And that's exactly what the legacy architecture doesn't do well. So it's particularly important in thinking this through. And I think there's also a view on services becoming more personalized and so forth, so the service innovation becomes very important. So you got to solve all those problems simultaneously. And then what Glenn said earlier about the distribution, you have deployment models just to make things interesting that'll go from centralized deployment but logically distributed to actually physically distributed. So you put all that together, the focus of the core is really critical because architecturally what you're trying to do in the core is quite different than what we've historically done. That was my point earlier about sort of the dumb luck category of having designed things in a distributed fashion just allows you to take advantage of many of those 5G capabilities like network slicing today and not have to redo it again 3 years from now or whatever. And I think that's really one of the very important points that people have to think about because a lot of the technology that's being brought to market today for virtualization still kind of progresses the monolithic nature of the legacy architecture, right? So it's great, you can put it out there and then what do you do 3 years from now? Start all over. So I think that's why it's become such a top of mind issue.
So it seems like it's fair to say, at least from the radio side of things, we know that for 5G there'll be a new air interface, right? And there'll be sort of a hard line between 5G NR and let's say LTE. But in the core, it feels like it's going to be more gradual, or will there be specific things that only take place in a 5G core that we won't find before that?
So NB-IoT will be an example of that would have change in core that is very different than what legacy cores had. And
connectionless.
Yeah, connectionless. And then scaling of that, independent scaling of that was also important. And then again, I will go back to in 5G we are attempting to do a very large number of use cases. If you look at IoT, Many times IoT is lumped together as one word, but it is actually a collection of many use cases, and as Glenn said, varies from criticality to shelf life. I mean, if you have devices that are going to be not perturbed or not changed for 10 years, do you really want a system where a change for a smartphone trickles down and brings down that critical system? So those aspects will become very important, and that's why I think innovation in core will continue to happen.
That's maybe as we sort of think about that, we've been talking a lot about distribution of the core network, and how we sort of think about distributing the network. Andre, maybe this goes back to some of what you guys are doing. I think it was probably, 18 months ago when John Donovan got up and talked about the core project. I think it was about a year and a half ago, right?
Yep.
So do you want to talk a bit, as I think about distribution, that's one of those examples of really taking that, sort of institutionalizing the concept of distribution. Can you talk a bit about that?
Yeah, sure. So CORD, which stands for, Central Office Re-Architected as a Data Center, kind of a kludgy acronym, but sounds slick. Basically, it was really about, how do we go out to the access, to the edge, and think very differently than what we've done traditionally in that space. And what's really interesting about this, and it gets back to this whole notion of distribution, flexibility, and what are the use cases? These traditional networks were really built as one size fits all, right? And as Nishi said, there's going to be a tremendous number of devices out there that aren't going to need to talk to the network as much as this smartphone sitting on this table here. And how do you do this in a resource optimized way, and also realizing that that device or that use case needs to be around for an extended period of time? And so how do you keep it relevant? And so what we did with CORD was we looked at some general use cases where we said, well, look, in the case of fiber to the home, which we did an example, we actually have a trial going on right now with it. What is the sort of minimal footprint that we need to provide a basic broadband service, and then layer on a video service? And oh, by the way, we could layer on parental controls. And then guess what? Certain controls extend beyond that particular access medium, extend to perhaps wireless. So I'll use the example of parental controls. The parental controls I put on the broadband for my family in the house, for my kids, I probably would want them to have those same controls on their wireless devices once they go outside the Wi-Fi network of my home. Well, why wouldn't you put that capability in the right place so that you could simplify and have this continuity? And that's really what CORD allowed us to learn and allows us to do. And we're learning a lot also that we don't need as much overhead. We don't need to have very complex routers, as an example, to do a lot of these things. So it gives us a chance to sort of rethink and redesign everything. And I know the session's about the core, but there's still a lot we can do at the edge. But how the core and the edge work together, I think that's the big opportunity that 5G will bring. And actually having the core sort of come after VRN, I think is very appropriate. And we will see a lot of sophistication and benefits that we will learn by having the core as a close follower.
Sort of goes to that distinction that Hassan was making in terms of logical versus physical core, right? It's sort of still the logical core, even if it's physically at the edge of the network. We may want to think about how, maybe do we come up with a name for it in the future? Probably not. We'll probably still call it the core, but it's core functionality versus the physical core.
Yeah, we're all engineers, so we're not good at naming things. So it probably will stay that way.
5G.
Yeah.
Actually, if I could add to that, at times, some of the aspects of 5G lead to false expectation of simplification. So there is a separation of control and user plane.
Yep.
Yeah.
That's good. But then there is expectation that one can centralize all control plane and leave the data plane distributed. Now, good. What happens if you do the narrowband IoT where the control plane is actually handling your data? And if it's not aligned with the vertical that you're serving, now you have a problem. And as Andrew explained, the same thing applies to core, right? I mean, you're going to do video, you're going to do parental control. Elements of control are going there too. So, we need to be careful when we look at some of the paradigms that we are supporting. That's good, but then not try to simplify where it's not aligned with the services underlying.
So we'll still be calling it core forever. Maybe Glenn, let's piggyback off this idea. We talked about 5G. I think Hassan was sort of making this point that to some extent there's a preoccupation on the core. We can talk about the core because a lot of what you need going forward, we're setting the stage for today, right? Mm-hmm. What we're doing with SDN, what we're doing with NFV, with virtualization.
Yes.
Obviously, you probably come from I don't want to say different perspective, but from an Ericsson perspective, you guys have generations of 2G, 3G, 4G, 5G. So you've probably seen sort of that continuum. I mean, how do we think of the 5G core, and how do we think of going forward versus what you've had to deploy in terms of 4G? How do we think of that continuum of what's getting deployed?
Yeah, I mean, I think we see the 5G core as an evolution of the 4G core. So all of the seeds that we're planting right now in the evolution of the 4G core toward network function virtualization, software-defined networking, setting up, not just the capability of instantiating network resources dynamically in software across the network, all of which are 4G concepts, that will extend into 5G. And there's some additional architectural changes that we will introduce into the architecture and the core over time as we evolve into 5G. But let's think of it as an evolution. It's not going to be a hard cut. And so we see a common core then that is the common core set of resources that we can set up network resources in the network dynamically in software to meet the needs of the application that's asking for those network resources. And that common core network is going to be a distributed cloud-based infrastructure that's distributed all the way out to the edge of the network, into the central offices, and all the way out into the eNode Bs in some cases, based on the needs of the application environment that network is serving. And then that common core is talking to both a 5G radio access network and a 4G radio access network simultaneously. And we'll take those network slices and we'll extend those network slices all the way out into the radio access network, all the way out to the device. So that's the idea of a distributed cloud, is that it allows us to, in software, define the network path through the core, all the way out into the radio access network, and where it's a common core that's talking to both 4G and 5G, creating a seamless evolution path going forward.
So that argues that to do this well, you have to have an understanding of 4G and 5G, which I think everyone on the panel would, right?
Yep, that's not to say that you couldn't introduce a 5G standalone application.
Understood.
Just as you can introduce a 4G standalone application today, honing back to a common set of core network resources. So maybe in an effort to, I don't know, get some debate, or at least maybe a little bit of argument here, how important is it to have an understanding of the RAN and the core together in developing a solution? So how important is it to have assets and to have an end-to-end solution? Does having RAN assets and a position in the RAN help you on the core, or is it not necessary? And here's where you're supposed to say, yes, it's important. So the other end of the panel can say no. But is it important? Is it not important? I mean, even when I talk to folks like Qualcomm, even they will say, yes, you need to understand the core, even though they're in the RAN, to make sure that they're doing things. How do those fit together, and what does that mean to you guys? There's always a benefit to understanding the end-to-end resources that are set up across the network. Because we're extending network slices all the way out into the radio access network. Narrowband IoT is a perfect example. I implement that in a specific way across the radio access network. When I'm serving up a network slice for a narrowband IoT application, I'm doing it across a very thin slice of the network resources in the RAN and extending that all the way into the core. Having an understanding of both of those environments is always an advantage in a design context. That's not to say that the same guy has to be building both, And it's clearly not the case today that the same guy is building both. But there's always, from an architectural perspective, an advantage in having a deep awareness of what's going on in the RAN to be able to effectively implement network resources in the core.
I'll be part of the yes side on this.
Okay.
So absolutely, you have to know both sides of the equation here, and in a way, especially the point about, this isn't something, a flash cut that happens overnight. This is a long evolution. LTE 4G will be around for quite some time, and certainly, all these different devices and use cases are going to have to coexist for this period of time as well. I'd also just give an example of take video as an example. 5G, probably the one thing people associate 5G with is, gigabit speeds, right? And it's not too hard to think about, whether it's from a downlink consumption standpoint, whether you're watching, 4K type videos, to an uplink scenario where your car is uploading video imagery of the road in front of it, so to make sure that you don't crash the car, right? So when you look at that, all of a sudden, the core becomes pretty relevant, because guess what? I've got to get those video images back somewhere, do some processing on it, and then probably take some action on it. So just having a great understanding of, how you get from the device to the radio network and a little bit beyond probably isn't good enough. You really need to understand all the way through to the other end to make that application successful.
I think the way the question came across, it'd be hard for any of us to disagree. I think if in terms of understanding,
Yes.
that clearly has to be there on both sides. And by the way, in 5G, it becomes even more important, I would say, because as we think about these 5G RANs, they're going to be, the view is that 5G RANs will be much more densified with small cells, so the signaling load and all that's quite different. So how that affects the network, even the very basic networking part becomes important. If you do the networking well, you can leverage the radio asset better. So having a good understanding of both is, I think, you can't live in this world without having that. I suspect where you were going was trying to make the point that is there an advantage to a large vendor like Ericsson being able to supply both? Is that an advantage? And on that front, I think we would, of course, disagree with that. And I'd say history's on our side. I mean, I think it's a fair statement that the best RAN vendors have not built the best cores. And that's a statement of fact.
So I guess
That's controversial.
Somebody wanted it.
Hassan and I will
Can
deal
I
with
get
that
out of the
later.
way here?
I guess you could turn that into a different direction, though, as when we first started talking about NFV and virtualization, right? It was network functions virtualization, right? And we talked about maybe some of the easier stuff was IMS, maybe not as packet, heavy. We moved into EPC. So is the next step for you two at the end virtual baseband? I mean, if we think of baseband and virtualizing the eNode B as just another step of virtualization, is that something that you could easily do?
So, I think, we should also look into the direction. You said two sides, RAN and core, but actually if you're looking at the holistic view of the ecosystem, there is a vertical that you're serving. And that vertical is also very important. And alignment of, as I said, entropy is very important, that what you're serving is aligned with the network, because you don't want to be serving a mission critical thing with a network that is going through a lot of change, right? So that aspect is important. And as Hassan said, there is enough going in the core that it requires proper attention. If the same company is trying to do both, that's fine, but that doesn't mean that there won't be specialist companies who would be innovating in core and providing you the innovation that is needed.
We kind of got some disagreement there. That's good. That's good. So you talked a bit earlier. We'll stick with you, Nisha. You talked a bit earlier about IoT, and maybe some of what is necessary thinking about, in the core for IoT. I tend to think that we don't necessarily see a lot of conversation about what you need to do in the core for IoT. Can you elaborate a bit on why we need to see, whether it's connectionless, architectures, how we need to be thinking about the core for IoT?
Right. So two things. One is in the morning, someone used the term that 5G is actually a network of networks. So, in fact, IoT itself is like that. You have many networks that actually build the overall network to serve a use case. Coming to core, there are few things that, at least I can cite two, big and small, that you could decide. One was that, as I said, like scaling, massive connectivity, and how you want to do, connectionless scaling of core. That itself is new, and that needs to be dealt with. And that doesn't mean the other use cases go away. For example, if you have security camera feeding HD video, that still needs to be handled. So all these have to be taken in stride, and that means core has to be capable of doing that, whichever way it does. The second aspect comes from densification. If you're going to address more and more coverage, higher frequencies and whatnot, then you have many more points terminating into core. And most traditional implementations of core made an assumption between the signaling timers and the number of SCTP termination for the recovery. And those things are built into their code base, and that's why you would see that as the number of eNode Vs increases, they have to have more instances. But even in a virtualized world, you don't want to be having 20 servers when it can be done with 4, and things like that, or you don't want unnecessarily VMs or processes. So again, the idea here is that how do you scale? Tomorrow, we might be required to migrate 100,000 eNode Bs from one set of servers to another, and eNode B should not know that something has happened. So those kind of things still need to be done.
So I think we're getting to the point where we have time for one or two questions. It looks like we have 8 minutes left, so we can have one or two questions. If we don't have questions from the audience, you got to put up with my lame attempts to get arguments. So I think we have one here.
Okay.
Or here. Looks like we have two. Look at that.
Hi, Vince Ferretti from Corning. My question has to do with how you see investment over the next several years. Is it, do you have to do the core first before you do the 5G upgrade, or does it happen together? So just wondering how you're thinking that will proceed.
I'm probably assuming that question was for me.
I think so.
The rest of us were too.
Yeah, so it happens together. If you think about what's happening now, just as the 5G standards here evolve, and hopefully soon we'll be getting them, you will see still densification being a big part of the strategy, especially you see some of the recent news out of the FCC over the last couple of months here with opening up the millimeter wave spectrum. This is pretty tremendous here. This is what's really going to drive a lot of speed here. The issue there with that frequency range, as we all know, is that the propagation is a bit of an issue. So you're going to have to get these small cells deeper into the network. So as that happens, that certainly will help with the LTE network, but that's also pre-positioning for what we will do with 5G as well. In addition to that, don't forget there's unlicensed. And so this sort of, again, this isn't a flash cut overnight. This will be an evolution here that happens. So you will see, frankly, a lot of investment from the standpoint of getting out that densification, right? Maximizing what we can do with the spectrum assets we already have and will have in the future, but also seeing what we can do with the unlicensed as well. And then on top of that, there's how do you manage all of this? Because now, having all of this, this multiple access points, small cells, macro cells, now you've actually introduced a lot of complexity that you have to manage. So there will be lots of opportunity for the software side of this to help manage that complexity. So I think you'll see investment all the way around in all segments that we touch.
Hey, so this is a related question. There's been a lot of talk about network of networks. When you think about 5G, how much of the existing hardware infrastructure today could support 5G in, over the next 5 or 10 years, or will, the move toward a more software-defined network require a whole refresh of hardware at the edge and infrastructure at the edge that looks very different from the infrastructure that exists today?
Well, I'll take a stab at that. I mean, I think that the whole target design of the evolution from 4G to 5G is that 5G and 4G are going to interwork in a very, very close way for a long, long time. If we just go back, 3G was always designed to be a replacement for 2G, and 4G was always designed to be a replacement for 3G. And we introduced a number of clever software techniques to make the handoff between 4G and 3G a little bit more seamless, but they were never meant to interwork. 4G was meant to be a replacement for 3G. 5G is not going to be a replacement for 4G. Those two are going to be in the ground. It's designed, 5G is being designed from the radio access network all the way back to the core to be interworked seamlessly with 4G, so that I can simultaneously run a channel at 5G up in maybe the 28 or the 37 to 39 gigahertz band with a 4G channel down at the 2 gigahertz band and aggregate those two together and hone both of those back to a 4G core. So as we evolve the 4G core from largely a hardware-based core today to largely a software-based, virtualized, network function-based core tomorrow that we can distribute to the edge, that will just continue to improve the performance and the flexibility of being able to set up those network resources, to improve the speed that we can set up those network resources, to be able to set those network resources up in software rather than using engineers' times to set up that network path, and to make the whole thing work more dynamically. But the 4G core of today will be substantially reusable, and the evolution path to 5G will just make it more dynamic, more software-defined, lower cost, faster going forward.
I might add just one comment to that, which is your premise about how much of the hardware space can support 5G. I would submit to you that even if 5G didn't exist, that the network have to evolve anyway.
Exactly.
For the economic reasons, for real economic realities. So I think the evolution will have taken place anyway, and as Glenn says, the groundwork we're laying now with virtualization will be usable into the 5G.
It's probably fair to say, at least in the core, much more of it's going to be reusable than in the RAN, where you're going to need a new air interface. But really, the core supports that in the RAN from a multi-connectivity standpoint, supporting multi-connectivity, as Glenn mentioned, across 4G and 5G.
Yep.
Well, if we don't have any other questions, I know that they're eager to get this all back on track. Any last questions? Well, I think we have one more. Maybe we have time for one quick question. We'll have to make it quick. It's a yes or no question.
Oh my, come on, Pete, I can't do that. This is Apkar Dhaliwal from Fluido. So my question is, where are we, what is the world going to look like towards 5G when we look at the trends towards more open source and more open interfaces?
Much cheaper software, right, guys?
Yeah,
You wanted it short.
Yeah.
There you go, cheaper.
I think open source is the trend in the industry. That is the inescapable trend in the industry. And the reason that it is the inescapable trend in the industry is it opens the door to so much innovation. The innovation becomes so extensible. We can tap into the brain power of so many more engineers. And so that is the reality of software development in our industry going forward. And I think there's a number of ramifications to that, but maybe the most important one is much faster innovation, much faster time to market of new services on the network by taking advantage of the open source communities.
I think we're getting a whole bunch of agreement, and it looks like we've got 15 seconds left. So if we can get a round of applause for the panelists. Thank you all very much.